All right, so your app is a massive hit. Users are flooding in, things are looking great, and then you start to hear the servers creak under the pressure. Well, first off, congratulations. That is what we call a good problem to have. And today, we're going to walk through exactly how you solve it, how to scale your backend from just one user all the way to millions.
This is the exact moment every developer dreams of, right? Your app is a success. But that success comes with its own, pretty serious challenges. See, it's not just about handling more traffic. It's about building a system that can actually grow and evolve without, completely falling apart under its own weight. So here's what we've got on tap. We're going to follow the entire scaling journey of an app, starting from that very first bottleneck all the way to reaching users across the globe. We'll break down all the key strategies you need to know step by step. Okay, let's get right into it. Think about it. Every great app starts out pretty simple. You've probably got just one server doing the whole shebang, handling user requests, talking to the database, dealing with file uploads, everything. It's nice and clean, super simple, and it's also the very first thing that is going to break when all those users start pouring in. So what's the first move? Well, the most obvious step on our scaling ladder is something called horizontal scaling. Basically, if one server isn't cutting it, why not just add more servers? It sounds almost too simple, right? But hold on, there's a really important, a crucial principle that makes this entire strategy actually work.
And this right here, this is the absolute heart of modern scaling. Let me give you an analogy. A stateful server? That's like a clerk at a small shop who remembers you personally and keeps your file right there on their desk. If that clerk goes on break or goes home for the day, tough luck. Your progress is totally lost. But a stateless server, now that's like a giant modern call center. It doesn't matter who you talk to because any operator can pull up your file from a central system they can all access.
So that's the magic word, statelessness. The whole point is that with this kind of design, it literally does not matter which server your request hits. It could be server A, server B, or server Z. They can all give you the exact same response because none of them are holding on to any unique information about you. And that is the key that unlocks real, powerful horizontal scaling. Okay, so how do we actually pull this off? Well, you can think of it like we're performing a kind of architectural surgery. We have to carefully move every single piece of state, that's the user-specific data, out of our application servers. So user sessions, they get moved to a shared, super fast memory database like Redis. All those file uploads, they get sent to a huge centralized storage service like S3. Once we do that, our app servers become these interchangeable, faceless workers, just pure processing power. Awesome. So now we've got this whole fleet of identical servers ready to go. But wait, how does a user's request know which one to talk to? That's where our new best friend comes in, the load balancer. It's basically a traffic cop that sits out in front of all our servers, and its only job is to direct the incoming traffic, spreading the requests out evenly. All right, so we've scaled our app servers, high five. But in solving one problem, we've kind of just created a new one. All of that traffic that's now beautifully spread out across our servers, it's all hammering our single, lonely database. We didn't really get rid of the bottleneck, did we? We just moved it one step down the line. Yeah, scaling a database is notoriously tricky, mostly because it's the one component that has to be stateful, right? It's where all the data lives. But don't worry, we have two really powerful strategies up our sleeve. First, we can create read replicas, basically read-only copies of our database. Or for more extreme cases, we can do something called sharding, which means we literally chop up our data and spread it across multiple smaller databases. And this is exactly why read replicas are such a total game changer. Here's a little secret about most web apps. Users spend way more time looking at stuff than they do actually changing stuff. So by creating these copies of the database that only handle the read requests, the looking at stuff, we can offload, get this, like 70% of the entire workload. That gives our main database some serious breathing room. But of course, there's always a catch, isn't there? Imagine this. You update your profile picture. That's a write, so it goes to the main database. Then you immediately hit refresh to admire your new photo. Well, that read request might get sent to a replica that hasn't gotten the memo yet. It's still showing your old picture. That tiny delay is called replication lag, and learning how to manage it is absolutely key. Okay, so at this point, our app is a beast. It's handling huge amounts of traffic. It's super responsive, as long as you live close to our servers. But what about our users in, say, another continent? Now we're up against an opponent you just can't beat. the actual laws of physics.
Here's the hard truth. Light travels through fiber optic cables at an incredible speed, but it's not instant. So a request that has to go from, let's say, Tokyo to a server in Virginia, that trip alone, just the travel time, takes at least 100 milliseconds. And that's before the server even does any work. The user feels that lag. You just can't argue with the speed of light. So if we can't make the data travel any faster, what's the solution? Simple. We make the distance shorter. And we do that with a content delivery network, or CDN for short. Think of it as a global network of mini warehouses. We store copies of our stuff, images, videos, whatever, in these warehouses all over the world, so they're physically closer to our users. It's brilliant. Now, as our app gets more and more features and our team grows from a few people to a whole bunch of people, scaling changes. It stops being just about adding more servers. Now we have to start thinking about the architecture of the code itself and even how we structure our teams to deal with all this new complexity. Check this out. Here's a really clever trick to make your app feel way faster, even when the actual work takes the same amount of time. It's called asynchronous processing. The best analogy is a coffee shop. When you order a complicated drink, they don't make you stand at the counter and wait, right? They give you one of those little buzzers and you go sit down. That success message your app gives you, that's the buzzer. The app feels super fast, while the slow stuff, like sending out an email, happens in the background. You know that simple one-server app we started with? There's a name for that. It's called a monolith. And look, monoliths are fantastic when you're just starting out. But once you have a big team working on it, things start to get painful. Every little change means you have to redeploy the entire application, which is super risky, and you're pretty much stuck with whatever tech you chose on day one. It just doesn't scale well for people. And that's where microservices come in. They're designed to solve these organizational scaling problems. The idea is to break up that giant monolith into a bunch of small, independent services. You might have one service that just handles payments, another that just handles notifications. This way, different teams can work on their own little piece, and they can deploy and scale it without getting in anyone else's way. It's about letting teams move fast. Whew. Okay, so we've covered a ton of ground here, right? We've talked about everything from load balancers to microservices. But I want to be clear. The most important part of scaling isn't any single piece of tech. It's really about having the right mindset. So if you remember anything from this, let it be these 3 rules. Number 1, measure everything. Don't guess where the problem is. Use your tools to find the actual bottleneck. Number 2, always go for the simplest solution that gets the job done. And number 3, and this is a big one, scale for the problems you actually have. Don't build this massive, complicated system for 1 million users when you only have 1,000. Solve for today and have a plan for tomorrow. Because at the end of the day, scaling isn't some finish line you cross. It's a journey, right? It's this continuous cycle of measuring, learning, and adapting your system and your own thinking as your application grows. So you might know all the patterns, but the real question is your mindset ready to scale?